we're going to go ahead and start on the next section. And I told you a story yesterday. I should have looked. We are doing 2 sections today and 2 worksheets today. Sorry. Okay, so let's look at 5.2. I just kind of want to, I don't want you to get, the reason I'm doing these videos, I don't want you to get confused. I want to walk you through it. I don't want you just to read this section because fractions are so important. All right, so look at 5.2. Now, yesterday we talked about, ways that you can represent fractions, ways that you can say fractions, what fractions mean. We learned about fractions being division, that kind of thing. All right, so today we're going to learn about, 2 different things. The first section we're going to talk about is mixed numbers. And we're going to take each section and do the worksheet, and do the next section and do the worksheet. They should be pretty easy, really. These are things that you probably you've probably done these before, but it will not hurt you to do some more. All right, mixed numbers. So since one of the ways to think of fractions is as representing division, we can use fractions to represent remainders to division problems. When we represent a remainder as a fraction, we're basically just completing part of the division, but leaving the part that's not a whole number as a fraction. For example, if we divide 5 muffins among 4 people, which we would write as 5/4, that's an improper fraction, we'd end up giving each person 1 1/4 muffin. So look at the how they worked the problem. So 5 over 4, 5 divided by 4. There they wrote, how we're used to, in the box, 5 divided by 4. Okay, it equals 1, but there's a remainder of 1. Or not a whole 1, it would be 1/4. Notice where it says or 1 1/4. Okay, the big 1, the whole number 1 there, represents the answer, the quotient, which was 1 whole. 4 goes into 5 1 whole time, with 1/4 left over, being the remainder. So let's look at the picture of it. So there's 5 muffins divided by 4 people. Okay, so here they go. They're going to divide. They're going to give each person 1 whole muffin. So there they gave each one 1 whole, because remember 4 goes into 5 1 whole time. But then there's 1 left over that they have to divide into fourths. And so they took that 1 muffin and divided it equally into 4 parts. And so each person gets 1 1/4. And notice that's what they did with their remainder. They didn't have, they had 1 whole muffin left over, but it wouldn't be, to divide it, you had to divide it. You had to divide that 1 whole into fourths. All right, so we would call 1 1/4 or 1 1/4, either way, a mixed number. A mixed number is just that. It's mixed up with a whole number and a fraction. And that's why we call it that. Now notice 5/4, improper, and 1 1/4, mixed number, represent the same quantity. I'm at the top of page 115. Okay, so that improper fraction 5/4 and the mixed number 1 1/4 was the same amount. They both represent the results of 5 divided by 4, only in 1 1/4 we've completed some of the division. If we were to think of 5/4 as 5 parts with 4 to a whole, we would still have 1 1/4, and there's the picture of it. There's the 2 circles at the top of page 115. Hold on. Yes? I'm so sorry. I had a phone call and I had to take it, and I was on there for a little while, so I kind of lost where we were. But I know we were at the top of page 115, so we'll continue here. So we were talking about 5/4 and 1 1/4 representing the same quantity when we divided it. The 1 1/4 just shows that we divided. So there we see, we can also think of 5/4 as parts of 4 to a whole. So then you would have 1 1/4. If you divided each set into fourths, then you would have 2 sets there, because you'd have 1 there and then 1 over there. You wouldn't need a 3rd one or a 4th one, because you only needed to color in 5 of those fourths. So 5 parts with 4 parts to a whole is the same as 5 over 4, which equals 1 1/4. So I hope that makes sense to you. All right, now we're going to learn two things right quick before we do the first page. We're going to learn how to convert from improper to a mixed number. Now remember, improper means the number on top's bigger, and a mixed number means that it's a whole number with a fraction. All right, so it's easy, very easy to convert between improper and mixed. Since a fraction represents division, all we need to do is complete the division, leaving the remainder as a fraction. Now, here's an example right in the middle of page 115. Rewrite 21/4 or 21 divided by 4 as a mixed number. All right, basically 21/4 or 21 divided by 4 means 21 divided by 4. When you divide 21 by 4, you end up with 5 wholes. Basically 4 goes into 21 5 whole times with 1 left over, 1 remainder. But remember, you have to use fourth. You have to use the number on the bottom. You have to keep that denominator. So let's look where we have the math work. This is right in the middle. So 21 divided by 4. We're changing this improper fraction to a mixed number. Just divide. So 21 divided by 4 gives you 5, remainder 1. And there's our answer, 5 1/4, because it goes in there 5 whole times with 1/4 left over. Now, if we think of 21/4 in terms of parts of a whole, you'd get the same answer. So 21 parts with 4 parts to a whole gives us 5 wholes and then 1/4 left. So there's a picture of it. There's 21 parts and each whole has 4 parts to it. So you'd have to have 5 wholes, and then on that 6th one you have just one of those. 21/4 equals 5 1/4. All right, now let's reverse that. Let's convert from a mixed number to an improper fraction. So again, we remember that a mixed number represents division. It's not hard. Let's take the mixed numbers 5 1/4 again as an example. Turn the page. 116. We want to re-express 5 wholes as division by 4. So basically what we're going to do is you're going to take, see at the bottom where it says, not on the bottom, right here on the page, right here, right there on 116 where it says 5 1/4. Basically you take the denominator, which is the bottom number, times the whole number, and then you add the numerator. So you get 21 over 4. Now I'm going to put something on the screen for you to see. I'm going to work that so that you can see it. Now we're not going to read the rest of this page because what I'm fixing to show you is what's on the rest of this page. So let me go ahead and put that on the screen. All right, so what they're showing you here is you have 5 1/4. All right, now we want to make, this is a mixed number because it has a whole number and a fraction. We want to make it into an improper fraction. You do the same thing every time. This is all you do. You multiply these two and you add this and then you bring this over. Okay, so 4 times 5 is 20. Oh, I'm sorry. 4 times 5 plus 1 gives you 21. Over, this stays the same. There we go. So we've converted back and forth. So it was 5 1/4 equals 21 21/4. All right, let's do another one then. Just an example of our own, of my own here. Let's see. No, that's not going to work. Cut this out. Okay, so let's go back. Let's go to the marker. Okay. So basically this is what we've learned. So let's take an improper fraction, like I'm just going to make up one. Let's take 6 over, no, let's not do that one. Let's do 7, pardon me, 7/4. That's improper. And we're going to make this mixed. Remember, we just divide. So, because this is 7 divided by 4. So 4 goes into 7. How many whole times? 1 whole time. With how many left over? 3. And the bottom number has to stay the same because it's 3/4 that you have left over. All right, that's how we do it. Now, to convert a mixed number back to an improper fraction, let me make one up. 2 and 3/4. Mixed number. Remember, we multiply these and add that. So 4 times 2 is 8, 9, 10, 11 fourths. See? Easy peasy. That's all we do. All right. All right, that's pretty easy to go back and forth. All right, let's look at the top of page 117. This is your keeping perspective. Why so many ways? Improper fractions, proper fractions, mixed numbers, division sign, division stairs, all are different ways of representing division. You might be wondering by now why we have to have so many different ways to record and work with quantities. The answer is because each one proves helpful in different areas of real life. Take improper fractions and mixed numbers, for example. Sometimes we want to look at a quantity as a mixed number. It's easier to talk about getting 1.5 yards of fabric than 3/2 of yards. But other times we need to look at an improper fraction. It's often helpful when adding, subtracting, multiplying, or dividing. The bottom line is this. God created a complex universe, and it takes us a lot of different tools in our toolbox to work with and describe it. If you start to feel overwhelmed by math's complexity, don't fret. Simply lift your eyes upward and think about how much greater is the God who created all the things we can hardly even comprehend or describe. Oh, the depth of the riches both of the wisdom and knowledge of God. How unsearchable are his judgments and his ways past finding out. Romans 11:33. Okay, that's a good encouragement to keep up with our math. All right, so what we're going to do right quick is let's look at 5.2, worksheet 5.2. Now, I'm not going to help you with it, but like the last one, kind of walk you through the process of it. Now, it's a front and back page, and then we won't be done. We got to do one more section. All right, so at the top, number 1, fractions and mixed numbers. All right, part A says circle the improper. Remember, improper is bigger on top. Then convert the improper fractions to mixed or whole numbers. So remember, just divide. Now, let's take take 5/5 up at the top. Okay, remember that's improper, so you'll circle that because that is improper. But remember, anytime you have a number over itself, when you convert that, it becomes one whole. Basically, it means you have 5 wholes and all are gone, or all are different, or all are being considered. So it's one whole. All right. On C, it wants you to convert the mixed numbers to improper. Remember, we multiply and then add, and then take that as the numerator, and the denominator stays the same. Okay. Now, on number 2, A and B, it wants you to just divide, just normally divide. On A, you'll have to write it in a box like on B. Just divide that. When you get your answer, your remainder, put that as a fraction, okay? That means if your quotient is 45 and you get a remainder of 3, so it would be 3 on letter B. If your remainder is 3, I don't know what it is, but if it was 3, remainder 3, you would write that remainder as a fraction. It would be 3/25 as a fraction. Okay. On number 3, it wants you to complete the division. Basically, in your head, just put equals, whatever it equals. Just divide. All right. List all the numerators in problem 3. Remember, numerator is the top number. All right. On the back page 5, 6, and 7, basically, you're just going to be writing like a problem. It tells you what to do on there and what you're going to write. You're gonna be making a word problem. It should be pretty easy. On 6, it wants you to define it, plan it, execute it, and check it. So, define it. You're just going to kind of write what you know. On the plan, write what you are going to do, what your plan is. On C, do the plan. And then on D, just check it. You don't have to like check it with your pen and paper. Just check and say, oh, does that seem right? Yes or no? And that's what you do on checking it. Okay? So I'm going to go ahead and stop right now. When you're ready for the next section, you can turn this back on and we'll do that, okay? Okay, I wanted to show you this so that you'll be aware. Now, if you have a number, if you have a fraction, say we have 2/3, and we want to get an equivalent fraction, okay, something that is the same as 2/3, but we want bigger numbers. All right, we're going to multiply this by any number you want to that equals 1. Let's multiply it by 10 over 10, 10 tenths. Now remember, this fraction equals 1. It's the same as 1. So this is the identity property of multiplication. Okay? So 2/3 times 10, 2 times 10, we multiply the top number, is 20. And then 3 times 10 is 30. Okay? Now, even though these are different terms, we say the numbers are terms, it's still the same amount. If you were to draw it or show it on pies, it'd be the same amount. These are equivalent. Now, I don't know if this is showing you in the book, but I'm going to go ahead and explain this to you. If you have a larger fraction, say we have, well, let's just take this and turn it around. Let's just say we started with 20/30ths. And we thought, well, I think I want to make this into an equivalent fraction that's smaller. Well, you know, if we make numbers smaller, then we divide, right? Okay. But now you can't divide by just any number like you can up here. You have to think, what's the biggest number that these have in common? Probably 10. So we're going to multiply both of those by 10, which is 1. But now you couldn't multiply it by 8/8 because those don't divide evenly by 8. You couldn't do 4/4 because this would divide, but this would not evenly. So it has to be a number that equals, it has to be a fraction that equals 1 that both numbers can be divided by. Then you just divide across. 20 divided by 10 gives you 2. 30 divided by 10 gives you 3. Okay, so if you want to go up, you multiply by any number that equals 1. If you want to go down, then you got to think of what they have in common and divide them down. And that's actually what our next section is about. If you'll look down at the bottom of 119 where it says simplifying fractions. In the next chapter, we'll use equivalent fractions to help us add and subtract fractions. But for now, let's take a look at using them to express fractions simply as simply as possible. If I've read 13 pages out of 26, it would be easier to quickly assess my progress if I wrote half than if I wrote 13 over 26. Equivalent fractions make it simpler to take in a fraction at a glance. Now, this simplicity gets magnified when working with larger numbers. For instance, if our book had 332 pages and we'd read 166, it would be much easier to say we're halfway finished with the book. So if you put 166 over 332, basically that's division, okay, and you think, well, what numbers, if I wanted to divide that down to make it more simple, to look at more simply how much of the book I've read, then you would say, well, what numbers can they both be divided down by? It has to be the same number. Well, they both can. 166 goes into 332, and obviously it goes into itself. So you would divide that number by 166, which 166 over 166 is the same as 1. So you just divide that down. 166 divided by 166 gives you 1, and 332 divided by 166 gives you 2. So then you could say you've read half the book. Okay? That's called simplifying. Look at the next page. To simplify a fraction where the numerator and denominator are whole numbers, keep dividing by fractions worth 1 until you reach a point where the numerator and denominator won't divide completely anymore by the same whole number, except of course for 1, as any number can be divided by 1. we would then say that the fraction is in its lowest terms. Now look at the example they have there at the top of page 120, 350 over 600. Okay, you think, well, I want to divide that down as far as it'll go to get a smaller fraction, which can help you look at something and say, okay, a fourth or a fifth or a tenth or 2/3 or whatever. You think, well, what numbers can both of those be divided by evenly? Well, 10. Let's go with 10. So divide by 10 tenths, which is the same as 1. So 350 divided by 10 gives you 35. 600 divided by 10 gives you 60. So you have 35/60ths. Well, I think that can be divided down a little bit further. So what number can both of those be divided down by? 5. So 35 divided by 5 gives you 7. And 60 divided by 5 gives you 12. So you come up with 7/12. Is that as far as you can go, or can 7 and 12, do they have something in common that you can divide down by? No, that's as far as you can go. 7 and 12 can't be divided any further by the same number, so the fraction is now in its lowest terms. 7/12 represents the same value as 350 over 600, but in its lowest terms. Of course, we could have divided by 50 right from the start, like 350 divided by 600, and divide both of those by 50, and you get 7/12, and you just skip all that other stuff up there. But sometimes you can't know right off the bat. You just keep dividing down until you get in lowest terms. Now, from here on out, this is what your gray box says. From here on out, it says to make your answers easier to read, from now on out, you should always convert improper fractional answers to mixed or whole numbers and simplify fractional answers to their lowest terms. In other words, from here on out, make sure all your answers are in simple terms. They're at the lowest they can go. Now let's look at keeping perspective. You may be wondering why we're spending so much time with fractions. After all, do we really use them that often in everyday life? Yes, we use fractions in everyday life. I use them. If you cook, you use fractions. If you sew, you use fractions. Just take a look at, if you play music, you use fractions. Take a look at the fractions on a measuring cup. Go to the sewing store and buy a 1/4 yard of fabric. Build a bookcase and measure fractions of an inch. Watch the 4 quarters of a football game. Play a quarter note on an instrument, or measure out 1/4 inch on that next greeting card you make. The main reason we're studying fractions in depth is because fractions are incredibly useful in representing division. It's easier to work with division when it's expressed as a fraction. For instance, today we saw how fractions make it easy to simplify the division. While this may not seem that useful at first glance, it becomes indispensable when we start algebra. Okay, so that will be a time from now. All right, let's look at worksheet 5.3. I understand this has been kind of a long lesson, and I apologize. I'm going to go ahead and stop this and go back to the screen. All right, so we're on our last page. Just kind of want to go over each little section with you so you're kind of familiar with what's going on. Remember, if you have any trouble, just let me know. So since we're at the top of worksheet 5.3, since simplified fractions are easier to read, remember to simplify fractional answers to their lowest terms and to convert improper fractions to mixed or whole numbers unless otherwise stated. So on number 1, circle all the fractions below that are equivalent to 2/3. Now, to figure that out, you think, well, let's look at 8/9. Let me go back to this. Let me go ahead and cut this off. I should have already done that, and I didn't, from the last thing that we had done. Yeah, it's hard to get all of these, but there we go. All right, well, let's get that little one. Okay, so let's look at this right quick. I don't know why this keeps putting me on gray, but that's okay. All right, so it says we have 2/3, and it wants us to circle all the fractions below that are equivalent to this. All right, the first one it gives us is 8/9. So in your mind, think to yourself, okay, to make 8/9, can I multiply this by the same number? Remember, it has to be the same number because it has to equal 1. All right, to get 8/9, well, what would I have to multiply this to get 8? You'd have to multiply by 4, and that would give us 8. Okay, and if I multiply this by 4, because remember, this must be multiplied by, this has to be the same number. This would give us 12. Okay, so 8/9 is not equivalent because you can't get that. All right, All right, let's check on the next one. All right, let's look at, let's see, 18/27. Remember, we've got 2/3. Now, you can do this in your mind. All right, let's see, to get 18/27. Well, to get 18 at the top, I'd have to multiply by 9, which means the bottom number would have to be 9. So let's see what that would be. 18 over 27. Yes. So 18/27 would be equivalent to 2/3 because you can multiply by the same number, which equals 1. All right, so that's what you're going to do on the rest of those on number 1. On number 2, you're going to form equivalent fractions. Rewrite these fractions by multiplying or dividing as indicated. So on A, 28/40, you're going to divide that by 4 over 4. Just divide across. What's 28 divided by 4? That would equal 7. What's 40 divided by 4? 10. So your answer would be 7/10. All right, on B, you're going to multiply across. Multiply 3 times 12, which gives you 36, and 4 times 12, which gives you 48. So you end up with 36/48. Okay? All right, number 3, you're just going to answer that one. Answer number 4, you'll have to look back in your book to get the exact answers. On number 5, you're just going to, like on A, finishing 5 out of 20 math problems. Now, what this wants you to do is it wants you to use what we know about equivalent fractions and express those. Sorry. It wants you to express these as in simplest terms. So let me go ahead and erase this. And I'm almost done. I know y'all are sick of this. Okay, so it says finishing 5 out of 20 math problems. Okay, so we're going to express that as a fraction. And now we need to put that in lowest terms, simplest terms. So think, well, what does 5, remember, to make it in lowest terms, you have to divide. So what do these numbers have in common? The biggest number they have in common? 5. So let's divide in our minds. You don't have to write it. What's 5 divided by 5? 20 divided by 5. Ta-da! So that means if you have finished 5 out of 20 math problems, you are 1/4 of the way done, or 1/4 of the way done. So that's what you're going to do on the rest of those. On number 6 on the back, you're going to simplify these improper fractions. Remember, we divide. The answers are going to be mixed numbers. You divide in your mind. How many times, whole times, does 2 go into 17? It goes in there, what? 8 times. So your whole number will be 8. How many would be left over? Half. 1 over 2. Okay. What's the matter? All right. My kids are just waking up, so we've had issues. All right, so we're finishing the back side of this page. On number 7, portions of $1. All right, if each quarter equals 25 cents and $1 equals 100 cents, express the change listed as a fraction. Be sure to simplify. That means divide it down as far as it will go. Okay, and number 8 and number 9. I'm going to let you handle those yourself and just see what you can do on those. I might use number 9 as a bonus question. If you get it right, if you get it wrong, that's okay. But if you get it right, we might give you some bonus on that. So, all right, so I think that's all for today. If you need help, if I wasn't clear, if you lost your place or whatever, let me know and I'll be happy to help. That's all now.